Hello. 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 Can we hear? Pardon me for a second. The usual gang of nonsense. I mean, the usual nonsense. Coming. Okay, what's happening? Okay. Hello. Hello. Can anybody? I just want to. Oh, hello, Josephine. Hello, Claudia. Hello, Alan. Hello. And that means you can hear me, right? And you can hear me. Okay. Thank you, Alan. I appreciate it. All right. Awesome. Hello, Maria. It's all right. I'm getting distracted. And hello, Stephanie, and hello, Logan, and hello, Shy, and hello, Paulina, and hello, Emily, and hello, Alexis, and hello, Jada, and hello, Katie. That was visuals. Okay, now chat. Uh, hello. Okay. Um, Yes. Hello, Josephine. Good afternoon, Alan. Hello, Katie. Good afternoon, Emily. Hello, Victoria. Afternoon, Eric. Good afternoon, Alexis. Good morning, Maria. Hello, Jenna. Good afternoon, Brandon. Good afternoon, Jado. This is like everybody. This is awesome. Good morning, Paulina. Thank you, Alan, for the feedback. Good afternoon, Logan. Okay, let's just get rolling. All right. I don't even remember what my promise was, but I want to keep going with sorry, I want to keep going with homework 4 right now. We're going to get right to it. And then we will circle back and we will still not have new homework. I think maybe the other sections do something different, but we will have, well, I'm not sure I can, we certainly won't have new homework due Monday. I may post something to keep us going for Wednesday, but we're going to have one more little break. Um, sorry, I'm getting all confused. I'm going to go straight to homework 4 right now, but I know that we still have to circle back to homework 3. Therefore, at least in this section, I am not. If I do post homework 5, it will be due. And in fact, I may do that, but it'll be due Wednesday, not due Monday, is what I'm trying to say. All right, let me just get rolling here. I'm sorry, but I know I forgot to do one thing. Hold on. Before I forget. And obviously, if you have any questions, if there's anything that's unclear, or if I can't remember where we left off, if I left off with anything unclear, you can put it in the chat right now. Just bear with me. But other than that, I'm getting the homework. I'm getting back to continuing homework 4 right now. Oh, I know where we have to pick up. Oh, there was an issue right at the end of class on Monday. Okay, hold on. I'm trying to do two. I'll say this while something's loading. At the end of class on Monday, yeah, there doesn't. Oh, there's no class scheduled Monday. Oh, yes, there's no class. Thank you, Katie. Of course, I should know that. Good point, Katie. Thank you. There's no class. All right. So either way, so just like a sort of a fair warning, I may post homework 5 to be due Wednesday. I might, just to keep us going in the curriculum. But again, don't, if it's, if you, we're still catching up with each other. So don't get too stressed about it if you see it or something. It's still the same system, like that if you turned it in a little bit later, it would, as long as you turn in something before I've ever mentioned it at all, I guess I could say that as a, if that reassures anybody. If you're ever worried, am I late with this or what? If you're turning in something before I've even started going over it all, you're good. Like, okay, just to say that. But thank you. No class Monday. Good point. All right. What I have to say right now, as a screen is loading, is that at the end of last class, I zoomed through the answers to a question in homework 4. And I very quickly said, oh, yeah, the answers are 40 meters per second squared, negative 40 meters per second squared, negative 40 meters per second squared, 40 meters per second squared. This was the question in homework 4 about the Audi and the Buick and the Camry and the dirt bike. So I very quickly said that. And then someone right after class pointed out I was going too fast and I made a careless error. I corrected. Oh, I guess I put this in the stream too. I'm sorry, but just to be clear, I corrected in the notes and I put in the stream that I was saying 40, but I actually should have been saying 4. And just to be clear, the reason for that is acceleration is change in velocity per time. And for each of those vehicles in the problem in homework 4, each of those vehicles, its range of speed was like between 10 and 50 or 50 and 10 or something like that. But each of those vehicles did it in 10 seconds. So each of my numbers should have been divided by 10. Somebody very respectfully and helpfully pointed that out right at the end of class. So just to be clear, all those numbers should have been 4 or -4 or whatever. And if you was, was it the other way around? Wait, it was the other way around. I said 40, but I said 4. Maybe, I'm sure if you're saying, was that true? Well, since you, wait, let me look. Okay, I'll pull it up right now. Maybe you're right. But I feel like, didn't I forget to divide by 10? Wasn't that the issue? Okay, I'll look in a sec. All right, so bear with me for a second. So now I'm pulling up two things.
No, yeah, I was wrong. My bad.
Oh, are you sure? Oh, okay,
Sorry.
okay. No, you're fine. You're fine. No. And you've been helpful through the whole thing. So, okay. All right. So in a second, all right. So if there's any issue on that, for anyway, like please put in the chat. And also, I hope you guys have noticed that I did put up a portal for people correcting me. And I'm not even sure if I designated in the portal whether you had to be correcting me or not. Like I'm not even sure. But so this is helpful with like you should do that. But okay, but I think we're good on that. If there's any issue, please put in the chat. Give me one more second because I'm just trying to pull up the sheet and make sure you have okay. The takeaway of that correction is that acceleration is not just change in velocity, it's change in velocity per time. Like the person who pointed out the correction, that's tacitly what they're saying. The point of the problem that I think we do need to think about, or what we should all think about, is that the big takeaway of the problem is from here on in, I guess I'll say this in English, from here on in, do not think, first of all, in physics, there's no such word as deacceleration anymore or deceleration. That's not a word. We talk about either positive acceleration or negative acceleration. And the thing to be clear about from here on in is positive acceleration. Oh, in fact, I think this is the next problem on the sheet. I might as well wait. Yeah, I mean, this is a summary of the next problem on the sheet, problem 5. All right, I guess I'll just get to it. All right, this is what, all right, I'm going to start talking. I'm sorry, I'm like all jittery. All right, so here we go. Homework 4 continued. Problem number 5. Number 5. Okay, 5. All right, and again, here I'm not going to do the 5-step. These are like English questions. I'm not going to do the whole 5-step thing right now, but okay. In question A, it says a particle is moving at a velocity of -17. What's its speed? I think I think you're probably clear on that the speed is just +17. Even there, they should have been more specific of whether they meant instantaneous or average or whatever. But okay, I don't think there's probably questions on that. What's a negative sign indicate? Okay, so the negative sign indicates direction, right? So one thing about this, again, for anybody who's just tuning in, I'm talking about problem 5 on homework 4. Question B, it says, what does the negative sign in the velocity indicate? Okay, and it indicates direction, but here's now the thing. Like and then it says, what determines whether a velocity is negative or positive? Well, what determines whether a velocity is negative or positive is the answer is whichever direction is previously, i.e. initially established, designated, chosen to be positive, negative. What I'm trying to say here, okay, this is important. Like, negative means going in a certain direction. It means going in the opposite direction of positive. Well, what direction is that? Well, 100% depends on what we've chosen to call positive at the beginning of a problem or the beginning of a solution or the beginning of an experiment. That is, it's always up to the physicist The physicist has a choice as to what is called positive and what is called negative, but the physicist has to make that choice. Again, I cannot emphasize this enough. It's really the point of homework 3 that we're going to go over on Wednesday. But it's also why in the 5-step method in DFP, we have a job to do anytime we're going to start a problem. We first make a diagram, and in that diagram, we make a choice as to, okay, from here on in, positive means east, or like in the Berlin Rome problem. Okay, from here on in, positive means north. We have to make that declaration in a diagram, whether or not a question reminds us to. It's actually the art of physics. I'm going to say one last time because I know this. When people struggle with how to begin physics problems, one thing that escapes a lot of people is all physics problems or solutions have to be done that way, with choices about what we're now going to mean by positive or negative. It's always true that positive means the opposite of negative, but as to whether it's right to left or left to right, we need to make a choice and then stick consistently with it. So, for example, in this problem in question 5, where it says a particle is moving at a velocity of negative 17 meters per second, it just says that. We're really kind of like, we have no perspective on what that means. I know it means the opposite of positive. That's all I know until I make a choice. Okay, I hope that's sort of clear. So that was A and B. So direction is very important, and being explicit about it's very important. So then C. Wait, did someone just something in the chat? No, everybody's here. Okay, no. Oh, no, the answers. Okay. So then C, in some experiment, some hydrogen atom is found to have positive. Okay, a hydrogen atom is found to have some positive acceleration for some segment of its motion. During that segment, is the hydrogen atom necessarily speeding up? Why or why not? Okay, so this is totally trying to relate back to what we scrawled through with the Audi and the Buick and the Camry. See, so I'm writing down, and after this, I'm going to change colors, but positive acceleration does not necessarily mean or equal speeding up. It doesn't. What positive accelerate? So, and this is important to everybody. You might have seen this in the last case, but let's be really clear. Like acceleration is change in velocity per time. Acceleration is change in velocity per time. What I'm really saying there that you might want to make a note of is acceleration's not change in speed per time. It's change in velocity per time. Now, I'm even going to say as a sidebar, one of the reasons this confuses people, remember in our little chart of like scalar quantities versus vector quantities, we have different words. Like we have the word distance is a scalar, but then the word displacement is the vector. And it reminds us we have to deal with positives and negatives, right? Then we go to velocity. Okay, the word speed is a scalar, but the vector word for it is velocity. We have to deal with positives and negatives. Well, with acceleration, please note we don't have two different English words. It's confusing. We don't have two different English words for acceleration. So I have to just tell you, like rigorously, now that we're up to acceleration, now that we're in physics, thank you. Okay. Oh, great. Okay, I don't know which example you mean, but okay, great. I appreciate it. Great. Thank you. I'm gonna keep. If you mean this one, I'll keep going for a second. Yeah, there's no two words. So it's really important to know in your mind, like that equation is saying in English, acceleration is change in velocity. Acceleration is a vector word from here on in. If we ever say acceleration, we mean acceleration is a vector. Like we mean acceleration, yes, caring about direction. We do. So if acceleration is change in velocity per time, positive acceleration means that the velocity numbers are literally getting bigger. The velocity numbers are getting bigger, right? Like if the acceleration is positive, it means the velocity is growing. That's fine. But remember, velocity can be positive or negative. So just to put the finishing touches on this, and this really does end up meaning a lot in physics, if for a if you picture velocities on a number line, like velocities could be -30, -20, -10, 0, +10, +20, right? These are all possible velocity numbers. So for the velocity numbers to grow, it could mean that it definitely means we're moving to the right on the number line, but it could mean, I'm going to write it on the next page. So, okay. So for I'm trying to write this in English because it's that important. Honestly, for velocity numbers to increase, it could be. I'm just going to spell this out. It could be like +10, meters per second, +20 meters per second, +30 meters per second, da 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 da. Or it could be like -30 meters per second, -20 meters per second, -10, right? Either of those would be an example. Either of those would be an example of velocity increasing, which means either of those would be an example of positive acceleration. But the thing about these two examples is they're fundamentally different when you look at speeds. If you look at the absolute values of those numbers, one of them, the absolute value is getting bigger. One of them, the absolute values are getting smaller. So that means in one of those cases, the speed is getting faster and faster. The object is going faster and faster. But in the other case, the object's going slower and slower. The summary of all this, forgive me if I'm like, I know some of you already get what I'm saying, but the summary of all this, positive acceleration means moving faster in positive direction, like moving, let's say we call to the right positive, or say we call east positive. If you have, sorry, I'm so distracted. Or so I'm distractible, I should say. Positive acceleration, it either means moving to the east while going faster, or moving slower while going to the west. Please stop me if you don't see that. If someone just walks in and says there's positive acceleration, that either means they're going that way, getting faster and faster, or it means they're going that way, going slower and slower. Similarly, and I'm going to say it one last time and then we're going to move on, but it is, I'm yelling because I just know from experience that this is not obvious to everybody. I'm not yelling because I think it's obvious. I don't think it's obvious, but I can tell you that it's super important to get straight. So similarly, we never say decelerating in physics. We say negative acceleration. But don't ever, please, automatically assume that negative acceleration means slowing down. It means slowing down if you're going in a positive direction, but it means speeding up if you're going in a negative direction. The last way I'm going to put it, and then I'm going to move on, is negative acceleration definitely does mean this. What negative acceleration means is that no, actually, I take that back. Negative acceleration means velocity is getting lower. Positive acceleration means velocity is getting higher. So negative acceleration either means you're slowing down while you're moving in a positive direction, or it means you're speeding up while you're moving in a negative direction. That's what we're getting at in this problem of problem 5. I'm going to take a breath for a second. Now, we really have to talk about 6. I'm going to go to 6 next. There's actually a lot to say about 6, but just are we? Okay. Yeah. Oh, okay. I'm glad someone had some kind of question. So Maria, yeah, for these like little exercises, yes. And you notice I'm doing the same thing. For these kind of like little checkpoint, making sure we're cool, right. You don't have to do the DFP and all of that for these. And honestly, there aren't, yeah. So yes, what Maria says, you don't have to drag that all out for these. And if that were to happen on an exam, if we had like a little checkpoint like this in an exam, same deal. Correct. You don't have to do all of that. Just make sure. Okay. Thank you. Okay, cool. So I'm going to go on. Is everybody? I'm going to go on to the last question. Okay. Now I'll try to be quicker about it, but the last question really is important. The last question, I'll warn you right now. I'm not warning. I mean, I'm sure people did fine on the last question, but it looks like just random math, or it looks like random thing about numbers. It's actually the purpose of this last question. Averages and midpoints. You know, yeah. Sorry, I'm realizing we are making more. I'm like all fluttery and speaking all fast, but we actually are doing fine and we are catching up with ourselves. So forgive me, but yeah, there will be a homework due Wednesday, not due Monday because we don't have class Monday and it's a sacred holiday for many people. But I just want to. There will be a homework due Wednesday, and just try your best. I don't think it'll be crazy, but just try your best. Blah blah blah. Okay, number 6, averages and midpoints. Oh, I was going to say the purpose of this question 6. We are going to derive an equation from this. So just like state, I just want you to know it's not random. It's going to lead us to our next equation that we need for life. So, okay. So it gives a bunch of sets of numbers. I'm not going to rewrite all the sets of numbers. I'm also, yes, like Maria just asked, I'm not going to do the 5-step method for this right now. Oh, and thank you, Alexis. I'm not. Thank you for saying so. Do you? Well, I'm not sure if you mean clarifying the physics or clarifying whether we write a DFP or not. But I'll take it either way. Okay, thank you. Okay, these lists, these numbers. I'm going to cut to the chase first. I'm going to write down what I think the answers are, the averages, because I'm sure many people got many of them right. So for these lists of numbers, all right, I guess I am writing that. The first one was like 1, 2, 3, 4, 5, 6, 7, right? And I think that the average was 4. The next one, the numbers were 4, 5, 4, 5, 6, 7, 8, 9, 10. I think the average was 7. The next one, 3, 5, 7, 9, 11, 13, 15. I think the average was 9. I'm sure some of us see a pattern here. That is the whole point. Then the next one, okay, very tricky. Oh, no, it's not tricky. Sorry. So the next one, I think the average was 27. The next one, I think the average was 11. Wait, do I? Yeah. I think the next one's like a little tricky because they like put the numbers out of order, but if you reorder the numbers, you can still sort of maybe see a pattern. So I think in the next one, the average was 11. Correct me anywhere you think I'm wrong or crazy. Well, don't correct me. I'm always crazy. Now, the next one, the average, this one I actually have to do. Sorry, maybe someone could. I think the average. So the average for the next one, to cut to the chase, is not 16. The average for the next one is about 14, 30, 55. 55 plus 35 is 91. 91. So 140 divided by 7. Am I right? Yeah, 140. So I think it's 20. Did you get 20 for the last one? I just did it in my head, but I'm gonna look at the chat. For the last one, you tell me. I think I got 20, but that actually seems too easy. Is that what did you guys get for the very last one?
I also got 20.
Oh, you did. I'll go with it then. Well, Maria got 20. All right. So who cares? Thank you. Anybody else want to dispute or, confirm or I really, actually, it's really unfair for me to just go with one person. Can anybody else confirm or deny Maria's 20? Okay, sounds good to me. Maria and Alexis. Okay, it's the Maria Alexis show. Okay, now, who cares? What's the point? Well, here's the point. Well, actually, there is a point. I'm talking so much and I'm talking in such a jittery way. Does anybody want to try to say what they think the point is? Like, did you notice a pattern or a technique? Or as the question, I think, guided you to say, did anybody notice a pattern or a technique that worked for a lot of these lists, but didn't work for all of them? Does anybody want to share? No pressure. Oh, I just got something in the direct chat. Nice. Okay, thank you, direct chat person. And I'm going to say, oh, and Pauline is raising her hand. Okay, cool. First of all, I'm going to say thank you for going into the direct chat. I totally respect why you would go direct chat. And by the way, there's one direct chat person right now, so I'm going to say I agree with the direct chat person. So thank you. And I don't know if that means you might even want to go public next time. But I'm also going to say I see that Paulina has her hand up. I'm going to call on Paulina in a second. But let me give you one more minute, just since you're with me. Can I encourage? I want to wait till at least I get one more answer in the direct chat. I won't, just take a risk. I just want to see, but then I will call on Paulina because her hand's up. But does anybody else want to say anything in the direct chat? Awesome. That is one more person. Okay. So you guys are with me. I'll also say the second, now I'd be happy if you said anything, but it does happen that the two people in the direct chat did say something I think is correct for what it's worth. So yay to you guys, gals, and of course you could submit for points. Now, Paulina, what were you going to say?
So the trick I used was if there was like in the sequence, if there was like an odd number of terms, I just picked the middle one. And then if it was even number, I just took the middle two and added them and divided by two.
Awesome. I totally agree. And that is what people said in the oh, and someone agreed. Oh, and Alexis agrees. Thank you. And also, Paulina, I apologize. 2 minutes ago, did I call you Maria by mistake?
I think that they also put something in the chat. So right when I said something.
Oh,
So
Samantha.
I think
Okay.
it was that.
All right. Well, I apologize. Okay, I think so. Okay, all right, but I do know who you are. All right, and both of you. Okay, yes. So what now about 5 people have correctly observed is that in many, oh, there's more in the chat. Hang on. Awesome. Katie, thank you. And we're getting a variety of people. This is great. It almost feels like a class. Am I right? Okay. All we're missing is a third dimension. And smell, if you think about it. Okay, that's a really disgusting thing. But have you noticed that? Like, that's the one thing that the internet does not, like, it's one day there's going to be like scratch and sniff books on. Okay, that's disgusting. What about, but it's just weird, right? Like every other sense, we actually somehow can transmit at least some version of through the internet, but you can't transmit smells. Have you ever thought about that? I don't know. That just sort of blows my mind. But all right. And it's probably a good thing. I mean, it's a good thing, I'm sure. But so for all of the for most of the lists, you could do this trick that various people are phrasing various ways, but basically you could pick the middle number, right? And when there was an obvious middle number, you just picked it. And when it wasn't obvious, and this is like, I'm just expanding on what Paulina said, like if there was an even number or something, you could still almost like invent a middle number. You could take the number that's in the middle between the two seemingly middle numbers, and that would be the average, right? And let me even point out further, just to be clear, even on number 5, that worked when the numbers weren't even in an order. Like, because number 5 was like 8, 6, 10, 12. It wasn't 6, 8, 10, 12. It was 8, 6, 10, 12. But you could just take the liberty of reordering it yourself and putting it in order and then plucking the middle, and you'd be right, right? So we didn't have to literally average out all of the numbers until we got to the last one, at which point we did. And that's why I had bumped on it, like I had to stumble on it and actually do it. And I don't know why I was lucky enough to be able to do it in my head. So what's going on there? Like, this is not a coincidence. What are we saying? What we're saying, what we're saying is there's this trick that works in certain cases, but not in other cases. What is the condition? Well, okay, so I'm going to write it down now. What we're saying, again, this is 6 averages and midpoints. The finding, like what we're discovering here. Well, first of all, when it comes to raw numbers, or when it comes to a list, of raw numbers, the mean is the median. Like that's really what we're saying, right? We're saying the mean and the median are the same thing. That if you want to get the average, that would normally require adding up all the numbers and dividing by the number of numbers, right? We call that the mean, right? Everybody knows that. The mean average, the arithmetic mean. That average, the one that we're looking for here, the one that requires adding up all the numbers and dividing by the number of numbers. It turns out, like, let me even say, sidebar, no, mean does not mean the same thing as median, right? We're all aware of that. The mean average is add them all up and divide by the number of numbers. Median average is the one right in the middle. They don't mean the same thing. Triple equal sign, like no. But in a certain condition, under a certain condition, in a certain case, they turn out to be the same result. You can skip calculating a mean and just calculate the median and know you'll be right if and only if, and please make a note if I've never said before, when I write IFF, that means if and only if, right? If and only if the numbers change by a constant amount. This is really what, like all of you in the direct chat, and like this is what Katie is saying, and Alexis is saying, and Paulina was saying, is that, or I think what they were noticing is that what's different about the top, like all of these numbers are in a pattern of some kind, right? Like some of them you have to rearrange yourself to see the pattern. Like number 5, you have to rearrange and put in your own order, but then you see the pattern. Now, even number 6 is still in a pattern. It's still in a pattern. The pattern is the perfect squares. I don't know if you noticed that or not, but it is a pattern. But just saying pattern in general is not good enough. What specifically we're noticing about the first 5 lists is that the numbers increased or decreased by the same number all the time. Like we were either always raising by 2 or lowering by, or raising by 5 or lowering by 1 or whatever, right? As long as the numbers change by an unchanging step, by an unchanging interval, by a constant interval, then the mean is the median, right? That's what we're saying. And I mean is like double equal sign. Now that's so that's already interesting. It just means from now on, if I see a list of numbers that's increasing or decreasing by a constant step, if I want to average them all up, I could save a lot of time by just taking the middle number. I also want to point out before I go on, in such cases, the median, that middle number, like, so here's the Paulina example. Like when I say the middle number, as I think it was Paulina, as Paulina pointed out, sometimes there isn't even an obvious middle number. Like in case when there's an even number of numbers, so it was like case 5, there is no obvious middle number. So she took the middle of the 2 inner numbers. She took the middle of 10 and 12. In effect, in her mind, she could have taken 10, added it to 12 and divided by 2, right? Like 22 divided by 2 is 11. She probably just pictured it. Oh, here's 10, here's 12. What's in the middle? Oh, 11. But by what she really did was take the average of the middle 2 numbers, right? But check this out. What she also could have done, I'm not saying she did it, but what she could have done is she could have note this for a second. This is about to become an equation. when Paulina said that even in list number 5, that even though there was no middle number, she could just sort of take the middle number, the middle of the two middle numbers, right? So she took the 10 and the 12, and she took them, what's in the middle of them. Well, in effect, she averaged 10 and 12. She added, I mean, I'm not saying she literally spelled this out, but 10 plus 12 is 22, divide by 2 is 11. What's interesting to notice is she could have done the next two outer numbers, like 6, and if you're looking at the list, if we take 6 and 14, sorry, wait, what is going on? Oh, the numbers are, sorry, I forget they're in out of order. They're in out of order. If we take the next two numbers in the sequence, 8 and 14, and add them together, 8 and 14 is 22, divide by 2, you get 11. Or more extremely, less confusingly, go all the way to the outer extremes. Again, remember that that list happens to be written out of order, so you have to put the numbers in order in your mind. But if you take the lowest number in that list and the highest number in that list, the lowest number is 6 and the highest number is 16. Add those two together, you get 22. Divide by 2, you get 11. What am I saying? Like, what's my point? My point is, when all the numbers are increasing or decreasing by a constant step, the arithmetic mean of the whole thing, you can shortcut it. You can get it really easily. Like, even if we had 99 numbers, we can get the average of the whole thing really easily by just plugging the middle number of the whole list, right? We could get the mean by just taking the median. But even without writing down the whole list, if we just know, in other words, if I just want to know what's the average of this, 1, 2, 3, 4, 5, 6, 7, all the way up to 99, even if I didn't write all those numbers down, the number that's right in the middle actually has to be the average of the endpoints. 1 plus 99 equals 100, divided by 2 is 50. Like, so I'm saying two things right now, and then I'm going to turn it into an equation. I'm saying when the numbers are increasing or decreasing by a constant rate, number one, the mean is the median. Like, if the numbers aren't doing that, then this is not true. It's like if or only if. But if and only if numbers are increasing or decreasing by a constant rate, then the mean is the median. That's point number one. And point number two is the median can be calculated by just taking the mean of the lowest and highest numbers. I can ignore all the rest and just take 2 and average them. No matter how many numbers there are, I could just take the lowest and the highest and average them, and boom, that will be the middle, and boom, even if that middle number isn't even named in the list, and boom, that middle number, the median, will be the mean of the whole thing. Okay, this is with raw numbers. Now, why is that? Why is that? Well, because we're increasing or decreasing by a constant rate, meaning that any amount of numbers to the right of the center is necessarily tipping the average by the same amount to the right as all of the numbers to the left of the center. Like, if you're always increasing or decreasing by a constant rate, whatever's higher than the average, whatever numbers are higher than the average, all have to be higher than it by the same amount as the numbers that are lower than it. It's symmetric, right? So this trick always works with raw numbers. Who cares? Why do I care about raw numbers? Why am I talking about it in the physics class? Well, this is why. Okay, imagine now that instead of these just being raw numbers, each one of these numbers is like a reading off your speedometer. It's not just like 1, 2, 3, 4, 5, 6, 7. It's like 1 meters per second at t equals 1. and 2 meters per second at t equals 2 seconds, and 3 meters per second at t equals 3 seconds, etc. So each one of these new numbers is a velocity reading at equal time intervals at a successive next second, okay? If that's true, all the logic we just said would apply to these velocities as well, right? If this, you know what, this is so important. I'm crowding at the bottom, and I always do that. Hold on. I'm not changing this, but I'm going to erase it and write it on the next screen. I apologize because it's just too important to crowd like this. So I'm going to turn the page in a second, but I'm saying we're going to make an analogy from this now, or we're going to make an inference from this. From here on in, imagine I'm not just talking about raw numbers. I'm talking about instantaneous velocities at equal time intervals, at successive time intervals, right? That's what I'm saying. So now if I'm picturing velocities, so I'm like driving my car and I'm watching the speedometer needle as it hits each new threshold at successive readings on my clock, excuse me, then I'm saying, according to the logic that we just discovered, if I find that the instantaneous velocity readings are increasing or decreasing, are changing in time, right? If they're changing by a constant amount, if in other words, every second the velocity changes by 10 meters per second or 5 meters per second or -3 meters per second, but if it's always the same interval every single second, then I can make this same inference about velocities. So I'm going to say, so if and only if this happens, then I can. So I'm going to say, if that happens, and if you want me to turn back the page, I will, then the average velocity, of course, I'm going to write this in the form of an equation in a moment, but then the average velocity is the same, like double, not triple equal sign, is the same velocity at the middle of time, literally halfway in the time. Yeah. Oh, the lowest highest I'm going to write this as an equation. I'm just going to say it in English one last time, or velocities now, this concept of averages applies. So if we have the luxurious situation where velocities are always changing by a constant amount, then velocity for an entire interval or an entire journey will be number one, the same thing as whatever remember, average and instantaneous don't mean the same thing. Remember that. Triple equal sign, we have two different equations, two different concepts. We have average for a whole interval between 2 points in space and time versus we have instantaneous velocity at any one point, right? But now we're saying, well, as long as velocities are changing by a constant amount, then the average for the whole thing will be the same value as whatever instantaneous velocity occurs right in the middle, right at halfway through the time. So now I'm saying average velocity doesn't mean instantaneous velocity, but they will, and they're often not the same. Like how fast I'm going on average does not mean the same thing as how fast I'm going right now. But if I'm changing my velocity in a constant way, then how fast I'm going on average will be exactly how fast I'm going one and only one instant, the instant right in the middle, right at t equals half of t, like right at t over 2. And also, what is that number? How can I get that value? It turns out, well, if I believe this trick, that number, the velocity I'm going right in the middle, will be the average of whatever my lowest velocity was, averaged with whatever my highest velocity, like added together divided by 2. That's part of what Paulina was doing, right? Because everything's symmetric if the change in velocity is constant. So what does this mean equation-wise? What I'm saying is thus. Acceleration. Now I'm talking acceleration. Like everything I was just saying was about velocity. But my whole discussion about velocity just now was like, if the velocity is changing in a constant way, well, what do we call change in velocity? We call it acceleration. That's what this whole sheet's about, right? Acceleration means change in velocity. So if the change in velocity is itself not changing, we're getting subtle now. If the velocity is changing, but always by the same amount, like you're gaining velocities, we went from 10 to 12 to 14 to 16. So the velocities are always changing. But if they're always changing by the same amount, so like if every second I'm gaining 2 meters per second, i.e. if my acceleration is always the same number, for example, 2, positive 2, if acceleration is a constant, then velocity for the whole thing will double equal sign initial velocity plus final velocity all divided by 2. Now, this is a big deal because in a second, I'm gonna pause to like write a list of all the equations we have so far, because now we're starting to build some stuff here. New equation. This is a new equation, what I just established, right? Those are a couple of things. It's an equation for average velocity. We're big on average velocity. We've been talking about average velocity for like a month now. Be careful. Yes, if you're thinking, wait, I thought we already had an equation for average velocity. We do. We now have 2 equations for average velocity, but they don't contradict each other and they're not redundant and they're very different. The old equation for velocity, the old equation, and we're not throwing away, like we need them both for the rest of our lives. The old equation for velocity was for average velocity was the definition of average velocity. What average velocity always means is displacement per time. Now that's a triple equal sign. It will never be wrong. And it's always still, if we had an exam right now and you ever didn't know what to do in the middle of the exam, when in doubt, you would write down that second equation, the one on the bottom of the page, because it is always true, no matter what. Now, depending on the nature of a problem, as you're going to see in the next homework and stuff, you might start solving a problem and think, all right, I wrote that down, it's true, but I don't have all the information. Like, I don't know, like kind of like with the Hill figure and the Grandma Grimm problem. You might start getting into a situation where you know it's true, and so you're getting full credit for writing it down, but you don't really feel like it's helping you very much because like maybe you don't know anything about the time or something like that. So we have this other this other equation for average velocity now, this new one, which is not almost ever the one I would write first, because this new one is a double equal sign. It is not a triple equal sign. It's not the definition. It's not what average velocity means. Average velocity doesn't mean that. It means displacement per time. But it's something that happens to turn out to be true about average velocity under certain very strict but common conditions in physics. If and only if A equals A naught, then the average velocity for a whole thing will be the average of the first velocity and the last velocity, like literally add them together, divide by 2. Only if A is a constant. Constant a lot in physics, but you need to know that A is constant in order for this to be true. So when in doubt, always write the other equation first. The other equation is always true. It's never wrong. This equation can be very useful and necessary when the first equation won't help, is not enough. Like if you don't know the time in a situation. But this equation is only true if acceleration is, oh, no problem, no problem. Thank you. This equation is only true if acceleration is a constant. I'll write one more thing about it, and then I'm going to pause and because I guess we're done with the sheet, which is good. I think that's the end of the sheet. Oh yeah, fourth equation thing. The website we talked about that. But I will tell you what that's about. Like that's the next thing we're going to do with this. Okay, when do? This new equation for average velocity, it is a new equation for average velocity. Again, it is not always true, but when it's true, it's useful in a way that the other equation is not. So you have to be careful about it. By the way, it's our only double equal sign so far. It's our first equation that is conditional. So you really do have to get used to it and use it with care. It's usually not an equation that a flash of insight in order to remember or to consider to use this equation. It won't jump out at you and make itself obvious. So first of all, you can only use it if acceleration is constant. But that's the only time it's true. But when is it useful? Well, it's useful certainly in one of my things. Just can you? Uh, you can't hear me. This may be a problem. Hold on. Can you hear me? It's working. Okay. Sorry, I don't know which. Can you hear me now? Can you hear me now? Can you hear me now? Yes. Okay. Okay. It may go out again, and then I have to switch the. Okay. Thank you. All right. I'm sorry. This is so annoying. Okay. All right. So first of all, the situation when you would use this equation, first situation is if you, as long as you know A is constant, obviously you have to practice that. You have to know for a fact that A is constant. That doesn't mean A is zero, but it means A is constant. As long as you know A is constant, and if T is not known, and T is also not what you're solving for, this is a good equation to bear in mind. That's number one. And like those T as like is like just not part of the problem, basically. And then two, even more important and more subtly, okay, the subtle thing, and we're gonna have to do an example, but the real purpose of this equation is when you know something about the interval between 2 points, like when you already know something about the average, like maybe from the other equation, like you know the displacement, you know the time, so you know the average for a whole thing. But what you're looking for in either a whole problem or a part of a problem, what you're looking for is some information about a particular point in the interval. When you know something about the whole interval, but you need the whole interval between 2 points, but you need to know something about a point, this equation is your best friend. And it's people often forget it, but you need to remember it under this circumstance. When you're trying to zoom in from an average of a whole thing into knowing what's going on at a point, you use this. Because again, I'll do a super quick example. Let me do a super quick example just to make this clear, and then we obviously have to go on. But it's good. We're done with the sheet, so that's good. Super quick example. Oh, sorry. hold on. Okay, so here's the situation. I'm going to turn the page in a second, right? And I know we have 14 minutes. The situation is a car drives 100 meters in 20 seconds. Like that's the only facts I know. It takes 100. It takes 20 seconds to go 100 meters. It does not go at a constant rate of velocity. It does not go at a constant rate of velocity. In fact, it starts from rest and it speeds up. Okay, so at first it's going 0, but then it's moving. So it's not a constant velocity, right? It starts from rest. It starts from rest and it starts building up speed and building up speed until it accomplishes 100 meters in 20 seconds. The one other fact I'm going to give you is that I don't know, it doesn't have one constant rate of speed. It has a rate of acceleration. I don't know what the rate of acceleration is, but I am going to tell you that that whatever that rate is constant, right? So its velocity is not constant. Its velocity is changing, but its change is an amount that's always the same, right? So its acceleration is constant. So those are the facts, okay? And I'm not telling you to do that. Well, maybe I will, but here's just the fresh example I'm doing right now. I'm going to ask a couple of questions. Question 1, what is V at t equals 10 seconds? That's question 1. Question 2 is, what is V at t equals 20 seconds? Question 3 is, what is A, right? Okay, and again, remember, V is changing every second, but A, which is the rate at which V is changing, A is the same all the while. Let me just think if I want to ask. In the interest of time, I'm not going to, you could try to do this right now while I'm talking. Feel free, if you're with me and or you're bored or whatever, feel free to just do this right now, but I'm not going to actually stop and force you to, or I'm not going to ask. If you want to put things in the chat, you can, but I'm going to keep talking just in the interest of time. So I'm going to say, like, how can I do this? Well, if I want to know the velocity at t equals second, if this were an earlier problem on these sheets, what you might think is, well, in order to get the velocity at 10 seconds, maybe I need to use the acceleration rate. Like you might think that, and that would be smart, but I don't know the acceleration rate. So I can't do that. What I'm going to do, my step 3 GDP in effect, maybe I should draw it out. My step 3 GDP is, I'm going to say, since I was told that acceleration is a constant, then I know that the average velocity, well, sorry, let me back up for a second before I even do that. That's true, but hold on. First thing I'm going to do is what I always do on all exams. So when I doubt, I don't know how to do something, I first write down my most reliable GDP. V bar equals, by definition, x minus x naught over t. Right? Oh no. Can you hear me now? You still can't hear me? Okay. It's in and out. All right, it's in and out again. Well, here's the problem. It's in and out. All right, I know we only have 9 minutes of class. I believe you that it's in and out because I know it's my other AirPod, and my computer microphone is now officially broken. Oh, I got to do. So now I'm using AirPods. So the other AirPod ran out of charge. This is not interesting, but I'm in the other AirPod now. It's the last like resort I have. I know I'm charging the other AirPod now, but for the next 9 minutes, hold on. Oh, so, okay. Thank you. All right. Sorry about the audio, but it's all there in the notes. If you have a great day, have a great day. Okay. It's all in the notes. Thank you. Have a nice day. Okay. Thank you so much. So yes, have a good week. Oh, have a week. Yes, have a good week. You too. Thank you.